Here in the session we are discussing about the module 1 and we are almost at the end of the topic, end of the chapter. We are discussing here with the ion selective electrodes. Example for it is glass electrode, and we also discuss about the determination of pH of the unknown solution by using a glass electrode. Okay, ion selective electrodes. In the previous class we discussed about the secondary reference electrodes, and example for it was a calomel electrode we discussed, and next type of electrodes is a ion selective electrodes. What are ion selective electrodes means, as the name says, ion selective electrodes. These electrodes will be responding for a particular ions in a mixture of ions. Okay, these electrodes responds for a particular ions in a mixture of ions. The different types of membranes available here are solid state membrane, liquid membrane, heterogeneous membrane and glass membrane. Okay, these four types of electrodes will be there. Okay, the membranes will be responding for particular ions in a mixture of ions. And in our syllabus we have glass electrode, and the glass electrode will be responding for H plus ions in a mixture of ions. Okay, coming to the structure of the glass electrode, it consists of a small bulb at the bottom of the electrode, which is made up of a special quality of glass by using SiO2, Ca and Na. Okay, and this glass membrane will be responding for a H plus ions in a mixture of ions. Glass electrode responds for H plus ions in a mixture of ions, and there will be a presence of a internal reference solution. Usually used internal reference solution will be 1 molar HCl solution will be used here, and there will be a presence of either the calomel electrode or silver chloride electrode will be there present in the glass electrode, which serves as a internal reference electrodes. Okay, so the glass electrode comes in combination with the secondary reference electrode, which will be called as a combined glass electrode, and there will be a presence of a platinum wire at the center. It will be served for external electrical contacts. Fine. So there will be presence of a special type of membrane which responds for a particular ions and a mixture of ions. There will be a presence of a internal reference solution. Okay, and there will be a presence of either silver chloride or calomel electrode inside, and the electrode is called as a combined glass electrode. And about the electrode, the glass electrode consists of a long glass tube with a glass membrane bulb at the bottom. The glass membrane is made up of 72% SiO2, 22% Na2O and 6% calcium oxide, and the thickness may be varying from 0.033 to 0.1 mm, and either silver chloride or calomel electrode is used in as an internal reference electrode. Okay, how the glass electrode works means, when the glass electrode is working, okay, what happens, the Na plus ions from the glass membrane are replaced by H plus ions from the solution. Okay, see here, in the glass membrane Na plus ions are there, which will be replaced with the H plus ions from the solution. So Na will be going out, in that place H will be attached. Okay, in this way the glass electrode will be responding for H plus ions and ignoring the other ions at the same time, and the glass electrode is represented as Ag bar AgCl bar HCl bar glass. Next topic is a determination of pH of a solution by using a glass electrode. Okay, how to determine the pH of the unknown solution by using glass electrode. Okay, we have to take the glass electrode and we have to combine it with a reference electrode like a calomel or AgCl. I told you previously in the diagram, no? So before, no, previous days the electrode was coming separately like this. Separate glass electrode and separate reference electrodes was coming, but nowadays, no, the glass electrode comes in combination with the secondary reference electrode inside. Okay, you can show in diagram, you can show by writing two diagrams separately. Okay, but practically it will be if you write one diagram and inside only if you show the presence of the calomel electrode or AgCl electrode, both are correct. Okay, you can write the diagram in both the ways. Okay, you got it right. You can write separately the glass electrode which is connected to any secondary reference electrodes like calomel or AgCl, that is also correct. You can write the two electrodes combined singly. Okay, like inside the glass electrode only you can show the presence of either calomel or AgCl electrode, both will be correct. Okay, so here what is happening, we have to take the analyte solution for which the pH has to be determined. Okay, and we have to dip the electrodes, which is the electrode assembly used here is a, that is ion selective electrode, and the secondary reference electrodes are dipped in the solution and they are connected to the pH meter. Okay, fine. So glass electrode is coupled with the secondary reference electrode like calomel or silver chloride electrodes and are connected to the pH meter. The electrodes are dipped in the analyte solution, okay, for which the pH has to be determined. Here the electrode reaction is assumed to be the reduction of the H plus ions, and by knowing the potential of the glass electrode and reference electrodes, the pH of the solution can be calculated here. The experimental setup is simple. The electrodes are dipped in the solution, analyte solution, and are connected to the pH meter. Okay, how to calculate the pH? We know very well that E cell is equal to E cathode minus E anode. Okay, here no, what is E cathode and E anode? Here the cathode is assumed to be the glass electrode and the anode is a secondary reference electrode like calomel or AgCl electrode. Okay, what is E glass? The potential of the glass electrode is equal to the Eg0, E is equal to Eg0 minus 0.0591 pH. Okay, substitute this Eg value in the previous equation, we will get Eg is equal to Eg0 minus 0.0591 pH, okay, minus E, that is potential of the reference electrode. Therefore, pH is equal to Eg0 minus ESRE minus E cell by 0.0591. Okay, and you know, if it is done manually, this is the calculations. You know, for us nowadays everything is digital, right? Okay, all the calculations is already done. When you just dip the electrodes in the solution, okay, digitally it will be just showing directly the pH. Fine, don't get confused. The apparatus what we use in the laboratory, pH meter, okay, that is digital. It will directly, so all this calculation will be, you know, it is everything will be done inside the instrument only. Okay, the software will be uploaded there, so it will show directly the pH of the solution. Fine. So once again, the main points what and all we discussed here in this session are, we have discussed about the ion selective electrodes. The ion selective electrodes are the electrodes which responds to a particular ions in a mixture of ions. There are 4 different types of membranes are available: heterogeneous membrane, solid state membrane, liquid membrane, and a glass membrane. In our syllabus we have glass electrode, that is example for glass electrode is a ion selective electrodes. Ion selective electrodes will be having a membrane, okay, that responds to a particular ions. So our glass electrode will be responding for a H plus ions in a mixture of a solution. Okay, and coming to the structure of the electrode, a special, the glass membrane will be there, that is made by a special quality of glass, that is made by using SiO2, Na2O and CaO. Fine, and that will be responding for a H plus ions in a mixture of ions, and there will be a presence of a platinum wire at the center which is used for external electrical contacts, and the electrodes comes with a secondary reference electrode inside, that is either calomel or AgCl electrode will be present inside the electrodes, and then the electrode can be called as a combined glass electrode. Okay, then coming to the determination of pH of the unknown solution, the electrode should be dipped in the analyte solution for which the pH has to be determined, and it will be connected to the pH meter. Okay, here the electrode reactions are assumed to be the reduction of the H plus ions here, and by knowing the potential of the glass electrodes and the secondary reference electrodes, we can calculate the pH of the given solution. How can we calculate? That is, we know E cell is equal to E cathode minus E anode. E cathode here is a glass electrode and anode is a secondary reference electrode, and we know very well E glass potential of the glass electrode is given by, it is equal to Eg0 minus 0.0591 pH. Substitute this value for E glass electrode. So it will become Eg is equal to Eg0 minus 0.0591 pH minus ESRE. Therefore pH is equal to Eg0 minus ESRE minus E cell by 0.0591. Okay, so this is about the construction and working of the glass electrode and determination of pH by using glass electrode. Thank you.